Hello, good morning, good afternoon, everybody. Thanks for taking time out of your day for this webinar. My name is Eric Toczek. I will be here to moderate this webinar as we go through. We have a great topic today talking about the media and entertainment workflow and specifically how it relates to legacy versus the next generation of workflow, specifically as we look at remote employees and remote work. Very topical as it is today, and I've got two great co-presenters here to talk through that. So first, let me introduce David Phillips. David, why don't you introduce yourself?
Thanks, Eric. My name is David Phillips. I'm the Principal Architect for Media and Entertainment Solutions at Cloudian. So my background goes back 20 years or so providing media engineering solutions for a variety of different entities, everything from feature film publishers to large enterprise broadcasters. The common thread seems to always, in all my roles, seems to be supporting media teams, and it typically boils down to providing a place to store all the content and an effective way to access, view, and edit that content. And that's what we're going to discuss today with our Cloudian partner, Storage Made Easy.
Excellent. Thank you very much, David. All right, and we also have Doug Soltesz. Doug, why don't you introduce yourself?
Great, thanks, Eric. So I'm Doug Soltesz. I'm the Director of Product Solutions at Storage Made Easy. Here I'm on the product roadmap team, so I'm a PM, and we've been making a lot of new features into our product specifically related to media entertainment and around the APIs and protocols of the storage that's involved in these workflows, like our partner Cloudian has with their S3 that you'll see a little bit later. I definitely have a lot of experience in remote workflows. I'm originally from the East Coast, over the New York, New Jersey tri-state area, and I was the CIO for a nationwide services company there. We had remote offices and workers in over 10 states, and over the years we had several weather-related events, including Superstorm Sandy, that really pushed our remote workflows to the max. And so if you guys recall, that's the hurricane that hit a couple of years ago, and it knocked a lot of our New York, New Jersey office offline for weeks. And so I'm excited today to be able to contribute to helping other people with remote workflows.
Excellent. Thank you very much, Doug. Thanks, David. So why don't we start by making sure we're all on the same page and talking through what a typical what we call legacy media and entertainment workflow looks like. You know, what are the different steps? What are the aspects of it? And then we can jump into a little bit about, you know, what issues arise in our distributed or remote workforce. So I think, David, why don't you go off and step us through this diagram, please?
Sure. Yeah, from high level, this is what you often find in, you know, news, sports, entertainment workflows for different organizations, where a production team goes out in the field for a remote shoot. They acquire footage and assets, and then they need to get those media assets back to headquarters where they can, you know, ultimately be securely stored and backed up. And then once they're available on those central storage servers, you know, the next steps, you know, in the content creation pipeline can take place, such as transcoding, editing, and finishing for final distribution, you know, at the end of the process.
Yeah, and I'll just note that this is, oh, sorry, Eric. I was going to say this is exactly how a lot of our customers, when I've worked with our customers in M&E, you know, they all have a portion of this or this whole process. So, you know, ultimately they've got to get data in to their data center. They usually have to send it out. That could be to broadcast. It could be to the next team. And when that data is in their data center, they're working with a number of tools, whether those are transcoding tools, editors, a combination of both, MAMs. And so, you know, from an SME side, you know, this is pretty common. I wouldn't even call it so legacy. Like, this is pretty much what we see at a lot of our, you know, customers today.
Yeah, excellent. Makes perfect sense. Yeah, legacy obviously not in the viewpoint of this is the old way to do it, but rather that this is not the next generation forward-looking way to address it. So I guess as we look at this workflow, you know, where does it break down? Where do the issues arise within this existing workflow?
Well, I think, you know, taking a look at the storage, you know, would be, is often the kind of useful to start there. So if we take a look at the traditional model that's been in use for decades now, as Doug saying it's still contemporary in use now. You have typically have a SAN or NAS server that provides centralized storage for the media organization in order to provide data protection against drive failure. Sets of disks are striped together as a RAID group, and then to provide further protection, the entire SAN or NAS volume is backed up to an LTO tape library set as a replica of that production storage. Now, because central storage servers, are expensive and they have limited capacity, the most valuable assets need to be archived to a separate tape set for long-term preservation. Essentially, backup and tape archive as two separate process and two different tape inventories. And ultimately, for complete protection, a copy of every LTO tape and the archive tape set needs to be physically shipped to an off-site facility, for disaster recovery.
Yeah, and where I really see this breaking down with the current kind of shelter in place is that you're not in the office, right? So your office may not be open, you're not allowed to go in, and so moving those tapes around is going to be a problem. I've certainly had plenty of tape drives and heads and whatnot break. That's why you have an A and a B side. On the NAS side, they're certainly a little bit more resilient. They have things like RAID groups that David brought up, a RAID 50, a RAID 60. But, knock on wood, I've only had one RAID 50 fail me. It's a little harrowing because, back when I had set up that RAID, we had 3 terabyte drives. It was a RAID 50. And you can have 100 drives, but if a RAID 50 is just a RAID 5 across multiple stripes, right? And so if you lose a drive, you need to switch that drive out and start rebuilding, because if you lose another drive in that same parity set, your entire storage system is hosed. So you can imagine if you can't get into the facility to swap out that drive, that can be a problem. Today, I think everybody should be using a minimum RAID 60 because you got these huge drives, like 8 terabyte drives, and the amount of time that it takes to rebuild, the amount of IOPS that's involved. If you lose a drive, the odds of you losing a second drive during that rebuild for that one parity set could be really high. So I see this as breaking down in today's environment.
Yeah,
and then
absolutely.
I see. Yeah, and then I still continuing on the idea of those tapes, I think that breaks down in a different part of the workflow. So, if we're looking at this picture right now, we're also seeing that you're shipping tapes, right? So you're shipping hard drives, you're shipping tapes. Obviously, that's very efficient, but it's not efficient if nobody is in the office. So if nobody's in the office to receive those FedExes, you can't get the tapes, you can't be handling, you can't be ingesting them into your physical workflow. And so obviously there are a bunch of technologies out there for file transfer today. We've got on the distribute side, we've got the Amazon cloud. It could also be on the acquire side. But really, I think that this part of the workflow, even though it can be very efficient in today's workflow, just completely breaks down with shelter in place. What do you think, David?
Yeah, I mean, Eric, if you pop to the next slide, we kind of really, I think the, physical media, is, like you say, it's still quite common, but the vulnerability of, I've talked to many customers, most people I know who use this kind of physical media workflow have at least one story of a package being damaged in shipment by a carrier, beyond recovery. So, it's anytime you're handing off a physical media to a carrier, you're essentially taking the risk that that's going to be damaged beyond repair. So, and I've also, I've had many conversations over the last weeks, about media engineers working from home, trying to support the infrastructure from home, and essentially having the highly mechanical nature of a tape library means that it needs constant care and feeding. If you have a mechanical issue, that often you essentially have to go up to the tape library unit And if it's not something you can fix yourself, you have to call on a support engineer, which nowadays, it's, getting access to the data center is the issue. So.
Yeah, I completely agree. And then, with those assets, now that, you're having a hard time getting them into the central data center, I think the next thing you have to look at is how hard it's going to be to work on some of those assets remotely. So, clearly some of your asset workflow, like your transcoding, your MAM and whatnot, hey, they're going to live on premise. That workflow is probably going to continue to work because you drop an asset in a certain bucket or a folder, and it's going to go through that workflow. But if you're an editor and you're trying to work on these assets remotely, right now you're thinking probably VPN. And I even saw in the news the other day that Cisco is having problems with VPNs. And you wouldn't expect Cisco to have a problem with VPNs because they're literally the networking company. But as we all know from purchasing VPN hardware, that hardware is rated for a certain number of simultaneous users. And what we're seeing today is that hardware is being stressed to the limit. They have more users working remotely than they had anticipated. Getting more hardware is hard. And this is even for literally the company that makes it, as well as having to make holes in firewalls. You've got protocols like SIPs and NFS that can be actually really chatty, and they can be wasting a lot of bandwidth. When you're working on an asset, you need to be able to pull that SIPs and NFS, and they're not geared for latency, for packet drops, and whatnot. So I think that much of your workflow continues to operate fine in your central data center, but I think there are certain applications that if you need to work with remotely just are not going to be a very good experience. David, what asset, obviously we only have a subset of applications there, but I would think Premiere, Avid, any type of editor is going to be one of the ones that's most contentious.
Yeah, and like you're saying, a lot of people I talk to, in the current time frame, the last weeks, as a lot of the engineers are like, yep, I'm currently trying to upgrade our VPN because it was never designed to have the entire workforce hitting it all at once. It was really just for, a small subset to be accessing. So it just does not have the kind of bandwidth for everybody to be working off of it. And like you're saying, Premiere and, Avid's Media Composer they're really designed for, kind of dedicated production storage, be it a local disk, a SAN or a NAS mount, and they're very sensitive to latency. Like if when you're essentially providing kind of real-time playback, on a video timeline, the difference in 20, 30 milliseconds of fetching the next frame can mean you're like dropping frames, or just that the application kind of freaks out and thinks that the storage has gone offline and is not accessible. So kind of like all that, the VPN scenario that you're talking about, where you're trying to mount, a NAS volume over VPN, it's just not tolerant to the packet, drops in the latency.
It goes back to that theme of data gravity, right? And I think I've heard you talk about that at other events, where your data pulls applications, it almost, it's like a black hole, right? It pulls everything towards it. And we've certainly heard a few people say, oh, I want to move my whole workflow up to the cloud. You just can't do that. You can't, if you're trying to do that right now today, you can't take a petabyte of storage and move it from on data center up to the cloud and then maybe bring that back when you're done because you weren't prepared. And so you need some way of now using that data where it's centralized but in a more efficient manner.
Yeah, and it's a good point where it's like, there's, it's also quite common right now to use public, storage services such as Dropbox or Google Drive for this kind of collaboration and asset sharing, and it provides a very good solution, up to for things like Word documents and scripts and notes and sharing images and things like that, certain small graphic files, up to like a terabyte or so, but it's not designed to, like you say, lift and shift an entire, petabyte or more media library. Because a lot of times, a lot of customers that we talk to have a legacy archive of, say a photo library that's 2 million, photo images. They might have a content library that goes back, decades, multiple seasons of different TV show, episodes that represents petabytes of storage for both the source files and the finished assets, or a stock footage, library, or stock music collection, sound effects. All of these kind of media libraries that editors and content creators, graphic artists are used to just having at their fingertips. It's not. It's like you say, data gravity. It's just too heavy to just lift and shift it up to a Google Drive, or Dropbox or something like that. So,
well, and the other thing to note about like a Google Drive or a Dropbox is that usually you pay for the amount of storage. You're not paying for ingress/egress fees like you do with Amazon, Azure, and whatnot. And so what they're doing is they're restricting the bandwidth because obviously there's a ton of people working remotely right now. And they just can't have you, if you put a terabyte asset up there, they can't have you polling that and pulling it multiple times. And so they're restricting bandwidth. They always kind of restrict bandwidth. We'll talk about this later when we get into some of the file acceleration technologies. But I mean, Eric, I think at the end of the day, we could pick on this forever.
Yeah.
But yeah.
Yeah. So why don't we then instead try to focus on now taking a look at some of these breakdowns that we talked about and really trying to piece together now what a next generation platform looks like that can solve all of those concerns. So Dave, why don't you kick us off? I know you started talking about the storage, the central data center assets there as potential weakness. What does it look like in a updated solution that solves for those problems?
Yeah, so as we've been going through these diagrams, I think storage is really the central storage platform is really the kind of the best place to start, because traditional file systems have limitations with scalability and remote access, as we've been discussing. So what does a storage solution look like? I think several key functions that we're kind of pointing out here. Storage needs to protect your data in a durable, highly available fashion, right? That's maybe the most important thing that it provides. You have all this valuable content that's coming in from remote productions from the field. It takes a lot of time, money, and expenses to fly teams around to these remote locations. So all this content actually represents, high value, real dollars and cents. So protecting those valuable assets in a way that's, reliable and highly available is really the most important thing. The next thing is that, the content formats, 4K and beyond, are creating this, a scalability problem, because the content, more and more content's being created, and it's being created at higher, larger raster sizes, higher, the content sizes, are scaling as the amount of production is increasing at the same time. So having a storage platform that's scalable in both capacity and performance, right? So typical storage, you might have like a NAS controller head unit, and you want to scale it, and you just add more JBODs, to that, and it kind of scales up, right? So, but you still have a limitation because it has a limited number of network interfaces on the controller unit, and at a certain point it maxes out on how many IOPS and how much bandwidth it can push through that controller unit. So having something that's scalable and easily scalable in a way that you're not creating an entirely, I've now maxed out my my primary unit, I can't add any more JBODs. My file system, has millions of files in it, and it's starting to kind of slow down when I do directory lookups. So having something that, you can scale without adding a whole separate volume, because then you have a data management problem of which volume is my asset on and which volume do I point my workflows to, And I think the third thing that, we're kind of really pointing here is providing access from anywhere, whether I'm in the office or working remotely. And that's where, having, an S3 API being just, a HTTP UR addressable storage domain where I can be, I can be down the hall or I can be, around the world, and, this storage domain, this global namespace is available, as long as I can, get access to the network. I think,
I think those are,
yeah. Go ahead, Doug.
I think those are really good points, David. And why don't I just jump in and ask you a couple of questions, because, sorry, Eric, but when we were talking earlier, we were talking specifically about the, I was talking about RAID and how I had lost a RAID 50, and everybody's lost in a NAS individual disk, and today it's going to be hard to jump in there and exchange disks. So obviously a Cloudian system, I think obviously, has disk in it as well. What is it about this system that's going to make it far more durable than any type of RAID?
Right. So, and it's right. It's one of the key differentiators of object storage. So the Cloudian Hyperstore object storage platform at larger capacity sizes and scale uses erasure coding for the local cluster data protection, right? So erasure coding, much like RAID, creates, I'm going to take a large file, I'm going to break it up into fragments that then I'm going to spread across all of the nodes in my storage cluster, so that I can lose an entire, I can lose a disk, I can lose a node, I can lose some sort of, component in the cluster, and the storage cluster behind a load balancer just routes around the failure to the next available instance of that fragment, right? So the difference is, as we were discussing with RAID, is that when you talk about erasure coding, you can have much more flexible erasure coding data protection schemes. So say in a larger cluster size with 16 nodes, you can have 12 plus 4 data protection scheme where I have 12 data fragments, and then I have 4 parity fragments in order to rebuild my media asset object. So that means that I can lose 4 entire disks in my cluster and still have access to that data. The other key differentiator is that once I go to replace that failed disk drive, I'm not having to rebuild every sector on that disk, which as you get to larger capacity sizes like 12 terabytes, now 16 terabyte drive, being available, it can take 72 to 96 hours to actually rebuild an entire high capacity disk drive in a RAID set, if it's able to actually successfully rebuild at all. Where with object storage, if the disk is 60% full, you're only rebuilding, you replace the drive, and then you're essentially repopulating all of the fragments that were stored on that drive, which, it's all kept track of in a distributed database across the storage cluster.
Yeah, and and that's the kind of durability I kind of wish I had back in the day, because if I'm understanding you correctly, if you have like an erasure code policy of like 8 plus 4, meaning you have 8 data pieces and 4 parity pieces, I can lose 4 drives and I'm fine. They can be any 4 drives. But I can also, if I say had 12 Cloudian nodes, I could even lose 4 entire nodes. So in 4 nodes represents more than 4 disks. It's some sort of like mathematical combination that I guess, you know, if you call your Cloudian rep, they could really drill, you know, a little deeper into that. But the other thing would be that, you know, if I've got 12 nodes, you were talking earlier about scaling out versus scaling up. You know, certainly I've had NASs or SANs, and I've needed to add capacity to them, and I just buy a JBOD and I plug it in, and it scales up. You know, what's different about this? Because you know, if you ask me, my biggest headache back in the day was that I'd buy a NAS, I'd have a certain amount of money in my budget, users would consume it pretty quickly, and then next year I'd have to go buy another JBOD or maybe 2. And you know, by year 3, year 4, when I went to go buy that JBOD, you know, maybe my interconnect on the back end was Fiber Channel, and now they're using all SAS, or maybe the drives are a certain type of SCSI, and so there was no ability to grow it across generations of hardware and whatnot. It made it for a forklift upgrade. So, you know, does Cloudian address that?
Yeah, and that's, you know, that's maybe one of the kind of you know, most significant drawbacks of traditional enterprise storage is that just that kind of like forklift upgrade that you're describing, where the new version of the software, because it's a proprietary hardware, you know, it's a hardware software appliance, right? So there's firmware running on the hardware in a proprietary fashion. So when you have new storage firmware comes out, it's only compatible with a certain generation of hardware. So Cloudian Hyperstore is a software-defined storage platform. So it is essentially abstracted from the underlying storage server hardware. We just use commodity x86 servers, you know, as the hardware in the solution. So we sell appliances, but, you know, customers, we have customers that supply their own hardware, and, you know, certify hardware with HP, Lenovo, Cisco, you know, kind of major storage server vendors.
And that can be a mix of hardware, right? So you can have start with a couple of 12 drive nodes, put in a 40 drive node. You know, one node can be running, you know, SAS 7200 drives. One could be running, if they have them, whatever, 15K drives. Is that a fair statement?
Yeah. You know, it's quite common to have customers kind of like you're describing. It's like, you know, in one budget year, you know, you buy an initial footprint, and let's say 8 terabyte drives are the sweet spot, you know, as far as commodity hard drives. As far as the price performance, price per gigabyte for large capacity 7200 RPM hard drives, you know, 8 terabytes in a given year is the best bang for the buck, right? Well, then you get 60 to 80% full on that cluster, and the next year comes around, and it's like, I need to expand my cluster, but now 10 terabyte drives are essentially the sweet spot as far as the best price performance, price per gigabyte. Sure. And in that scenario, you know, you add a new storage node with the larger capacity hard drives to the cluster, and in the background, the Hyperstore storage service automatically rebalances all of the existing user data across that new capacity range, and takes care of that in a very automatic fashion. Where I've had personal experience with like expanding the capacity of an existing SAN file system, which now, you know, let's say my SAN was set 80% full. Now I have, you know, like a JBOD, like you described, that is 0% full, and the rest of my disk RAID sets are still 80% full. So now I have this imbalance across, you know, the lungs in my file system. So try to, you know, the idea is to, with the Hyperstore platform, is that you can expand incrementally as needed, and anytime you add a node, it's not like I have to stop my file system and the volume goes offline. You can add a node with no downtime, and it just, you know, in the background handles expanding the capacity range and adding that node to the cluster.
Right. And so I think the last point that you made was about the S3 API, and I think the S3 API is a benefit not only in the storage, but also when we talk about some of those other problems, right? The remote workers, the acquisition, distribution of assets. And so, I'd like to highlight the S3 API as a benefit there, because one of the things that we can do with the S3 API is if we start talking now about the acquisition and distribution and not shipping tapes, not shipping hard drives anymore, it's good to have an API that's internet ready, right? Something that we can send data over. And so one of the ways that we can do this is by leveraging that API in something called MPUs, where we can take a very big a file or object and send it in and reassemble it. And maybe if you just want to spend 30 seconds or a minute telling me a few of the clever things in that S3 API that may even relate to some of these other problems that we're going to talk about.
Yeah, when Cloudian developed the Hyperstore platform, in 2011, they chose the Amazon S3 API, which is it's essentially a public SDK, as the API of choice for a next generation storage platform. And that's proved to be prescient because in this day and age, the Amazon has been so successful with their public cloud service that the S3 API has become the industry standard for object storage interface. And like you're saying, it's inherently designed, because it's designed as a public cloud service. It's inherently designed to be accessed over the wide area network over an HTTP URL. So every single asset in a Cloudian storage cluster has a unique URL that, like you're describing, which becomes very handy when I need to either share assets with other third parties, or remote workers, or I need to, essentially look and browse at the assets in my cluster, from distance. So, and that's, the storage platform and the API become really powerful when you combine it with a solution like Storage Made Easy that provides that, an elegant interface that has an index of all of my storage silos.
Sure. Why don't I talk about that? Go ahead, Eric.
Yeah.
Yep, no, I was going to say, it seems like a good segue in as we talk about the acquisition and distribution of those resources. So we talked about that being sort of a issue in the existing or legacy workflow. So how is this solved in the new workflow, Doug?
So in the new workflow, what I'm going to do is I'm going to say that, if people are shelter in place and we can't be shipping tapes or hard drives around, what we need is a better way of sharing this data, right? And so David brought up before users using Dropbox. I brought up some of the issues with Dropbox that maybe they're currently, not maybe, but they're limiting bandwidth because of the way that you pay for their platform. The other thing with Dropbox is that you're going to take that data, put it into their platform. You still have the data gravity. Now maybe you have to bring it into your corporate data center. So with the SME appliance or system, we can create shared links that work directly against the Cloudian in your data center. It can work natively against the S3 API. We can also work with a number of other types of storage that you might have, whether that's proprietary or legacy CIFS, NFS, or something proprietary like the Media Grid software, the agent that you have to install, or GPFS, different systems where you have to install an agent. And so we have our own ability to allow you to create shared links and to then move that data using a technology called MStream securely into your data center. So it's going to be running over HTTP with TLS 1.2, AES encryption. And one of the unique things that we do is that we parallelize the data streams. And so this is going to be for the scenario of using a shared link, or another scenario that I see often is what I call the meet-in-the-middle approach. The meet-in-the-middle approach is where you either don't want to give somebody a shared link directly into your storage, or you've already decided that in order to exchange data, you're going to put it in, say, whatever, Dropbox, Amazon, Google, Azure. And so that meet-in-the-middle approach is, we have a bucket, we're going to share it, and so we need a technology that can go out, index that bucket, not have to ingest all the data through it, and then pull that data into my corporate data center. And what we've seen some people doing is using these little clients on their laptop where they're going out, they're indexing, like say a CyberDuck, an S3 bucket, and then they're going to try to pull that into their corporate VPN, or into their corporation through a VPN. And so now what you have is the data coming from that bucket down to your laptop on your home internet link, then trying to go back out. It's just an absolute nightmare. And so I'm going to be able to show you, in fact, I've got a little demo planned, if you don't mind, where we're going to be able to, David and I collaborate by either sharing links, and he can send the data directly to my data center and put it on a Cloudian device, or where I can go out and I can pull that data from, say, Amazon S3 anywhere in the world into my corporate data center without any of these issues. So if you're looking at my screen right now, what you can see is I have an SME environment set up. I have a number of different cloud providers or on-premise storage mapped. One of these is my Cloudian US, so this is in my data center. And so what I want to do is I have a bucket. So Cloudian creates these things called buckets. We represent them as a folder, and it's empty right now. I'm going to create a subfolder in it that's actually called a prefix in S3 Talk, and I'm going to just name it Webinar Clip. And so now I want David to send me some assets. I want to acquire assets. Of course, it could work the opposite way. And so I'm going to create a shared link via URL that I could email. I'm going to send expiration on it because I don't want it if he sends an email to get into somebody else's hand. I just want it for 3 days. A drop folder means that he can put data into it. I could also make it read-only. And then I'm going to set a password on it just to handle that. A little bit of extra security here. So I'm going to generate this link. I'm now going to copy this link, launch my email. David, I'm going to write you a quick email, so ignore the email you're about to receive. I'm going to paste that link in there. Yep. I'm going to hit send. And as easy as that, you're now going to have a link. When you click it, you're going to be able to just right in your browser upload all the assets that we're working on for this webinar. Now, the next thing I want to do is show that meet in the middle approach. So let's say I have an AWS account, or we're sharing AWS accounts, and I'm in the US right now. I'm in the West Coast. But let's say that I'm working with somebody in Europe, maybe one of these football teams, and so they've got some data in a bucket in London. And so if they've got this Vertigo clip, and I can preview it, I can play it right now. In fact, again, I'm in California, and yet it's pulling it, and I'm previewing it, and I'm scrubbing it with a little bit of latency, obviously, but directly against an S3 bucket out in London. If this is the asset that I want, and I want that clip plus the MFX, I can just copy this entire prefix right into my Cloudian system on site. And so I can move data without it coming through my own personal laptop. I can do this right from the web and bring it right into my environment. I could also do this between, if you do have some of that legacy. So I think StoreNext is a partner of Cloudian's. If I do have a StoreNext and I want to migrate some of that data into Cloudian, we can do that same kind of, instead of meet in the middle, the M-stream data acceleration between storage in your data center, and you can do this all remotely. None of it flows through your laptop. We're going to translate all the APIs, and we're going to do it in a super efficient way. We do parallel data streams for smaller files. For large files, we're going to use our technology to break it up into pieces. When we break it into pieces, we don't proprietize your data like other people do. It's going to land in a non-proprietary way, like that MPU, David, I was talking about. Do you want to explain to them what an MPU is real quick?
Yeah, I mean, it's just part of the Amazon S3 spec for, stands for Multipart Upload, where you take a file above a certain size range are automatically broken up into smaller, chunks for transfer. So it allows to kind of maximize your network bandwidth, or if it's across a wide area network, your internet bandwidth. So in your experience, Doug, how fast can M-stream go? I mean, like if I've got a 10 gigabit network in my facility, and I'm going, like you say, from a SAN or a NAS volume across the 10 gig network to my Cloudian cluster, how fast can it actually go?
Sure. We can fill that 10 gig link. We've done intra data center test. We've also done intra data center tests, and so It depends on a couple things. So obviously, you can't have 3 spindles in your Cloudian, but as long as you have enough IOPS and spindles in CPU, we can do that. One of the things to note is that sometimes MStream can use a decent amount of CPU, because when we're working with something like the S3 API, which is secure by default, right? So it's going to be HTTPS. It also has content signing. That can be an expensive operation on the CPU, because essentially we're encrypting not only the data, but we're signing it, which is very similar to encryption. That signing, think of it as like an MD5, like a very advanced one, and it's how you know that the person that's sending you the data is the person without them sending a key or password. If you're using other APIs, some of them send you a token, and that token lives for a certain amount of time. Amazon has or at least the S3 API has a little bit different take on that. They can be a little bit more CPU intensive.
Yeah, I think what's the key differentiator, though, in what I'm seeing from this is that it's not unlike other file acceleration solutions like Aspera, Signiant, and things like, and solutions like that are based on UDP. You can actually get benefit from this both locally and across the wide area network. So it's not a point-to-point protocol call like those UDP solutions.
Right, you don't have to install any proprietary software up in the Amazon cloud to convert it from TCP to UDP. Likewise, if you're on-prem, it really makes no sense if you've got rack A, rack B, one of them is running, let's call it NAS, the other one's Cloudian, to take your data, convert it from TCP to UDP, and then back from UDP back to TCP to go, 100 feet with basically no latency in the data center. So, we work for the intra and the external.
Right.
But then that same technology is going to help remote workers, Eric. And so, thanks, you brought up that slide. So that same technology is going to work with the remote workers for a couple different reasons. The first one is when you're using the SME system, we're going over HTTPS. There's no VPN required. We're a scale-out solution. So going back to my Cisco analogy, look, Cisco has a great solution. They make great VPNs, and for maybe some of your workflows, that's what you have to use. But if you're using our technology and you've got a VM or two spun up, and then all of a sudden your entire workforce is working from home, you just spin up a few more VPNs, and with modern CPUs, we're going to be able to handle that workflow. We're going to integrate in security, so LDAP AD SAML, that's why I showed in that last video where I can pull in your users, and we can audit actually I didn't show that in the last video. In fact, I want to show that in the next one. And then we can audit your events. And then what we're going to give you is the ability to work with like Premier or Avid with a software that is not CIFS, is not NFS. It's going to have a local mount point or a drive letter. It's going to look and feel like it's just a normal drive mount point, but it's going to handle that latency. It's going to cache things locally. It's not going to fall down your application if you get disconnected for a short period of time, because it's caching things, and then when you hit save, it's going to reinitiate, because we're using these type of web protocols that are geared for latency, for lossy networks and whatnot. And if you guys like, I've got a little video outlining one, how this would work, and two, some of the security aspects of it.
Yeah, let's take a look.
All right. I always want to say, Eric, roll the clip. All right, so I am in my environment right now, and David has uploaded a clip to that webinar folder, and you can see that there are 2 assets in there. So now I want to give access to this clip to some of my users. So I have a user, Doug, named after myself. I'm going to go into my organization users. These users can be pulled in from AD, SAML, LDAP, or our own local database. We can also pull in your groups. And so Doug's a member of 2 groups, one called editor, one called archivist. So let's give the editors permissions to work on this. So normally if you're working with like CIFS and you're working with NTFS, you know how to do this, but how do you do it with S3? Well, what we do is we're going to take this bucket, we're going to convert it into what we call a team shared folder. So I right click on it and I say convert to team shared folder. For those of you that use Microsoft, this is equivalent to sharing out a folder, but it doesn't matter that it's a different API. So now there's a little person on it. You'll notice a few of my other buckets in this environment have people on it. That means that they're shared folders. Next, I want to layer on security, and I want that security to be like NTFS. So I'm going to go into permissions. we are secure by default, and so I have no permissions. If I go down, I can find that editors group, and I can give them read-only access. Now, of course, we can do other type of NTFS-like permissions, but for now, let's just give them read-only access to this bucket. And so now my users could read the Vertigo clips, they can read the webinar clips, but I want them to work on it. So I want to break the inheritance at this point, which other systems may not be able to do. And so I'm going to go into the subfolder permissions here. You can see this inheriting that editors group, and now I'm going to break that. And so I'm going to say editors can do read-write. Now, it doesn't always have to be a group. If I want to add an individual person like Doug, or I guess in this case Ron or Daniel, I could add a single person in. And so now these users are going to be able to work on these assets. And so let me show you what this looks like, because obviously you're not going to open Premiere up in a web browser. So let me launch a Windows desktop and give it a second. RDPN. And there we go. All right, so I have a Windows desktop, and installing our cloud drive allows us to talk over our API and mount this as a drive letter. So in this case, I've mounted as the S drive, and so in the S drive, I'm going to see all of those shared resources that the admin has given me access to. So if I click on this S drive, it's going to now pull up all the assets I have access to, and there's that bucket called demo, along with other buckets or prefixes, or even entire accounts of multiple buckets I have access to. So you can see I've got demo here, and I've got demo in the Windows environment. So let's go into that, and as you can see, it's just like working with SysNFS. I've got those Vertigo clips that are read-only. I have the webinar clips. I go into clip 1. Here are the 2 assets that David uploaded. One is a ScreenFlow file. ScreenFlow is an application like Premiere, but it only runs on Mac. And then here's a proxy file. So why don't I just play this proxy file, because ScreenFlow is not going to run on Windows. So I double-click it, and it looks like it's launching, what is this called, Media Player. And then if I start scrubbing through it, this is the video I just showed you guys. But you can see the M stream is pulling this down. It's pulling it down in accelerated fashion. It's cached locally. It's going to have a very good user experience. Now, if I want to work on the ScreenFlow, let me switch to my Mac, because let me bring that down. Here we go. I'm in Mac Finder. Instead of mapping this as a drive letter, our software is going to map it as a map point. You can see, again, the exact same virtual folders, and these folders correspond to what I'm seeing over on the admin side that's shared out. So, for example, that London bucket. If I go back into the demo bucket, I go to that clip, and now I double-click this and launch it with ScreenFlow. My app's going to launch. It's going to start caching the data. There we go. And I have my app open. And this is going to be a good experience now. So now if I go and start to scrub through this, I'm able to scrub through this video. And the reason this is going to work and work better than a VPN is if I get disconnected, it's okay. The data is now cached locally. If I have latency, it's okay. We're going to handle for it. And I don't need that VPN. It's not going to be a chatty protocol. So at the end of the day, my experience is going to be much better for trying to work, edit, use clips with this type of software. And it's going to be easier for the admin. They don't have to open holes in the firewall. It's just HTTPS. Let me show you how the admin would kind of look at that security. So if I go to organization, we have audit logs. So as an admin, if you're not accustomed to allowing people into your firewall, your VPN, you're probably a little nervous now. So if I look in our audit logs, what I can see is that user Doug at my pretend company MediaCope logged in. Here's where Doug downloaded or accessed the MP4 via the Windows tools and the IP address and date and time that they accessed it. If I look on this list, 2 more down, there we go, is the ScreenFlow. And so if I open this up, I can see that Doug came in from a different IP address, which is my local Mac. And I can also see the time and what tool they use to work on this file. So if you're in a current environment where you secure everything, this is going to be a great asset for your admins. The next thing I want to show you is real quick, I'm going to launch SSL Labs, and I just want to run a security check against our system. Again, our system is secure by default. We're using fail-to-ban, we're using SE Linux, we have our own firewalls integrated into it. And so I'm going to run this just to show you how the ciphers are. I'm also going to run this against Dropbox, and I'm not trying to pick on Dropbox here, but one thing, I'll let the test kind of show you. So Dropbox has two endpoints. One of these is IPv6, IPv4. We're going to run the test against the IPv4, and I'm going to switch back to the test being run against our system. So with our system, it's secure out of the box, and you can increase that security as you want. And that's important because these media assets are very important to you. You want to have the utmost, the newest ciphers, the TLS 1.2. You want to make sure that you're getting like an A+ rating, that everything has to be secure by default. And so we can control that. You as the admin can control that. Like I said, out of the box, it's secure by default. Whereas with Dropbox and some of the other guys out there, there's been recently in the news that with everybody sheltering in place, they've had more activity, and they also have people with legacy clients. So they actually care about that guy with a 5-year-old Android phone that can't run TLS 1.2. So what have they done? They've re-enabled, and Azure and a bunch of other places have done this, they've re-enabled older protocols. And I'm not saying it's insecure, but it's opening up for compatibility reasons vulnerabilities. And if you're using our software, you don't have to make any of those sacrifices. You don't have to. You're using our tools. You're using the latest ciphers. You're using TLS 1.2. You don't have to go to a third-party platform that may decide for profit to relax a little bit of security so that they can get later generations, say Windows XP, working with their platform again. And so that's kind of what I want to highlight. Any commentary or questions there, David?
Yeah, from a high level, it's, everybody needs remote access, especially, in the current, climate, but not compromising security. Like how do we open up our central, facility infrastructure to our remote teams without compromising security? So I think it's a, obviously very important because, like you're saying, there's, you can't. It's not a time to lack security because there's just as many, let's say, nefarious agents out there who are looking to exploit, exploit the crisis for, for their own ends. So, which, Eric, if you want to pop to the next slide, I think, one of the things that's, kind of dovetailing off of that, kind of wrap up in summary on the Cloudian Hyperstore platform. I think we kind of highlighted all of the, the key attributes, about data protection, scalability, being an API, S3 API-based object storage platform that's scalable and, provides a single namespace for all of your assets, however large you grow it. One thing I do want to touch on before we go, though, is that, with the newest version, we've added the support for S3 object lock. And this really squarely addresses the issues that we've seen around ransomware attacks, right? So it seems like every week, goes by, you hear or read a report of a new organization that's, suffered a ransomware attack. And so it's, really top of mind, for most engineers and IT teams that I talk to. So the Cloudian Hyperstore, this is part of the Amazon S3, API stack, and it's, the newest version of Hyperstore. We support object lock, where when data is written to a bucket where this is configured, that data becomes immutable. So it's essentially impervious to the encryption, from a ransomware attack. And, there's, lots of times you read organizations, the only recourse they have once they've suffered, encryption from a ransomware attack is to actually pay the ransom, which can be up to millions of dollars. So it's, we're seeing a lot of interest in this, in the backup space, but there's, media asset libraries as kind of historical attacks like Sony, et cetera, have shown they can have real consequences, for a media organization.
Excellent, thanks. And now, Doug, why don't you wrap us up on the SME side?
Sure. So, SME, we've been in business since 2009. We have a number of clients in the U.S. and Europe. Those are our major focuses. I think I've shown you guys today that we give you a single pane of glass management into all of your assets. Those can be on NAS, SIFs, Cloudian, Azure, Google. We have over 60 different connectors for both the cloud and on-premise. This is going to allow your users to easily share and distribute content both internally and externally. We aren't able to show you today, but we have some advanced search features where you can find your media or other content, obviously permission-based, just by doing a simple search. So if you're looking for an asset across, your StorNext, your Cloudian, and the Azure cloud, you're easily able to find it. When you're moving this around either inside the data center or outside the data center, we accelerate your file transfers, or for the end users doing that. And then, surely if you contact us for a demo, we can show you some really advanced things where we're using some AI or ML intelligence, where we can take a proxy clip, send it to somebody like, say, Google, and we can have it tag. So it can find famous people, it can identify objects, it can do scene detections, it can do speech to text kind of transcription. So, the platform has a lot more than just what we showed you today, but I wanted to highlight today how we can help in today's current remote workflows.
Excellent, excellent. Thank you, guys. There's a good overview of current state of how things exist today in the M&E workflow, what things look like in a next generation platform, and how it fixes some of those issues, especially as we find ourselves in shelter-in-place or remote workforce. But what I'd like to do now is open up and allow the audience to ask questions. We actually have a couple that have already filtered in. So anybody out there, if you have questions, feel free to type them in chat, and we'll go and get them answered. So why don't we start with the first question, and it looks like this is probably towards David. So the question is, we have a hard time adding capacity without disruption. Am I able to add capacity to Cloudian non-disruptively without impacting our operations?
Yeah, it's good question. I think we touched briefly on it, but the whole design of the Hyperstore storage platform is a distributed Cassandra database on storage nodes in a cluster. So every node in the cluster has a copy of all that metadata and the cluster configuration metadata. So when you add a node, you essentially notify the cluster that you have a new node available, and it goes about repopulating populating that new hardware node with the shared distributed database, right? So and then at that point that that service comes online, then it goes about as a secondary background process of redistributing all of the existing user data across that newly available capacity. So because every node in the cluster is serving API calls and read-write requests, it is just it is a true scale-out storage platform. So if one node is down or if one node is coming online, this system behind a global load balancer just take care of routing all requests, all read and write requests to available nodes in the cluster. And that's how we are able to have essentially a no downtime, both upgrade, add capacity, add node, or also a maintenance event where we replace a failed hardware.
Excellent, excellent. Okay, so I have time for maybe one more question. This person's asking, what's the process to feed our data into the file fabric? How long does it take to move all of our assets into the file fabric?
Sure. So I think there might be a little confusion there. Our file fabric is not a gateway. So with a lot of gateways out there, you actually have to ingest all the data. So you stand it up, the data goes in because they store it in a proprietary format. We do a learn in place. So what we do is you deploy us. We're a virtual machine, or optimally a virtual machine in this kind of environment. So you're going to have a Hyper-V image, a VMware image, a KVM image. We have images for all the public clouds. But you're going to deploy our image. It's going to go out and learn your data. So it's going to connect to the native S3 API, SIFs, NFS, whatever it is going to learn that data. And then when you put data in, like I was showing, I guess I didn't get to show the back end on Cloudian, but if you put data in through SME and it lands on SIFs, you can access that SIFs directly and work on the file. We don't proprietize it in any way, shape, or form. So you could be up and running with us in a matter of hours just by deploying a VM, and then we can ingest that at a rate of a few thousand files per second.
Okay, excellent. Well, thanks. That's all the time we have for today. If we didn't get to your questions, please feel free to follow up with us. You see our contact information on the screen, and you can reach out to us either at cloudian.com or storagemadeeasy.com for more information. Thank you.
Thank you, everybody.
Thanks, everyone. Thanks, Eric.